Oh, it's
Is it recording?
now it's recording.
Is it?
Yeah. Yes.
Okay. So this it is recording, right?
Yeah.
Okay. So it is recording. Okay. Let me start over again. Okay. To write an OpenGL program, we have to include this header GL cut. Right. Cut here means utility. Right. As usual, we include this statement using namespace standard. Okay, that's how we write C++ program. Okay, and we have a main. Okay, and then this is the number of arguments that our program have, and this is the pointer pointing to an array of arguments. Okay, so we call this command cut init. Okay, and provide these two parameters. The pointer to this argument is integer, and the pointer to the arguments, okay, or the information we provide. So this is the initialization. Okay. Now, before we proceed, let's try to compile this. Okay, and see if it works. Okay. So we're in the same directory. Okay. So this we just call it job. So it's a C++ minus C. Okay. Now you may see an error. Right. Okay. So you can see that, okay, you have error. That's why we want to compile along the way that we write the program. So because we have some mistake, whenever you see some mistake, we should inform it. Okay.
Professor, can I ask you a question?
Yes.
Can I turn off one of these lights to make the screen a little easier to look at?
Oh, turn it off.
Can I?
Oh, okay. You better.
Yeah.
This way. Okay.
Thank you.
Is it better? Yeah. Okay. Okay. This would be ARGC. Okay. So there's a mistake. So we compile it again. Okay. So now you see that there's no error. Okay. So I fix the error and then we proceed and we continue. Okay. And next, okay, we define how we display the graphics. So that's a standard. At this moment, we say cut init display mode, how we display the graphics. So we use cut single, which means we're going to use single buffering. Okay, that would be faster. Okay. But later, we do more sophisticated graphics, especially when we do animation. We need to use double buffering to avoid flickering graphics effects. Okay. But at the moment, we keep it simple. We use single buffering. Okay. And also, we define the display mode is OTP. So this way, these two bits. Okay. And you can check whether you have the mistake anything by compile it. Again, no error. So we continue. Okay. And after that, you can define the window size. Okay, they say cut window init window size. We start with init okay. Window size. Okay, we can divide our window size. The graphics window size will be, say, for example, 600 okay, wide, and the height is 500. So there's the window size. So we define the window size. Okay. And after that, okay, we have to define where we want to put the graphics window, our graphics window on the computer screen. Okay. So we start from the top left corner. Okay. So this is 0, 0. So maybe we start from say 400, 200. So we use this command, cut, init window or window HUI. Init window position. 400 from the left, 200 from the top, and you can try compile.
How do you save?
How to save that?
How do you save the file or?
Oh, this is just the VI editor. You just press escape and then a colon W. This is sorry. Here. I say escape. I press escape and colon. Okay, you see the colon here, right? And then press W.
Oh, okay.
And then it says that it is written again. So I save it. Okay. The VI editor. This is the position. Okay, 400. 400. And now we use this command to create the window. Cut, create window. Okay. With this title. LTV0. And we can do some initialization, use another function that we are going to void init. For more initialization. This is the basic. And then we define the cut display font. So this is the callback function to display. So this specifies the callback function for display. Okay. And then after this, we say cut may loop. And this will make the program go into an infinite loop, waiting for events to happen. And we are almost done. Except that we need to define this function, void display. Okay. Display function, how to display it. Okay. Doing the details later. Okay. And now we can try. So the order. Okay. And so this is almost complete. See, if we could get an executable, we compile this, control, You may see an error. When we could produce the object file. Okay, yes,
Are you recording this session right now?
Yes, this part of this.
yeah.
I was just curious where we can find it later on.
Oh, where you can find it? It's EWD. Okay, it is in this directory. Home, home, class, CS420, 24S, so. Yeah, so you can copy that in this directory. Okay, these are available to you, to all of you.
For me, class is empty.
For what?
When I try to, I go to look at the list of the directories, it shows class, and then after class, it's empty.
CD, you use the command CD to change directory. CD, just type in this home, capital U. Okay. Then you can go to here.
Yeah, I did that, and then after I went there, I did ls, and it just shows class, and that's it.
You have to go further. Class
And
CS420.
then when I open class, there's nothing in class.
The CD class.
CD to class.
Yeah. CD class.
And these Zoom sessions are gonna be attached to your,
I'll post it on the website.
Yeah.
Like it seems like this sounds seems like push on the web. Okay, coming back. So you can see that there's an error because we cannot find these functions. Okay, even though we could compile that without error if we just need the object file. Okay, because we need the library. We need to link the library. So we need to do a minus, but it means to link with this library. You can see that now we do not have any error. The minus L gut means to link with the gut library. Okay. So you can see that we have generated this executable job. We can execute it. But we don't have anything yet. But you can see that. So we define this the size, right? 600, right? 600 and 500 pixels. The width and the height, okay, and the position. Okay, like here. Let's move it a bit. The position 400 here, and 200 from the top. Okay. This corner, the initial position, 400 from the left, 200 from the top. Yeah, it was here address. The initial position. Okay. So that's what these functions define. Okay. We define the window size, okay, 600 pixels. Okay, means and 500 pixels high. Okay. And you need window position. Okay. 400 from the left, 200 from the top. Okay. So that's the first step. Okay. And now after this, we can do some init. This will call the init, right? Initialization. These are also the standard. You put it. We have to do this. Clear color. One. So basically, this command means to clear the color buffer. So what you see at the end, the information of the colors are stored in a buffer called a color buffer. And here we clear the color buffer with these values with white color. As we discussed before, this means the red, green, blue, 111. So that means the color buffer will contain white color.
What's the fourth point?
Yeah, that's a good question. There's a 4 parameter here. This, at the moment, you can ignore it. It means opacity or the transparency. Okay. At this moment, we don't need to use it, so we can ignore it at the moment. Okay. But we'll discuss that in the future. So basically, we clear this color buffer with the white color. Okay. And this define a clear color, but this command, that's the action, GL clear, GL color buffer bit. So this command defines the color. This command is the action to clear it. Now, let's compile it, and see what happens.
It's taken a while.
It's not take that long.
Maybe you have to save first. Maybe save a CPP file.
Uh, Okay. It says GL undefined reference to the symbol GL clear color. Okay, so this, okay, you can see that GL is not gut. Here we use gut. Okay, and here is GL. So we use another library. Okay, what we need to do is to link to this OpenGL library. Okay, not gut. Okay. So now we don't have the error. Okay. And draw. Okay. And now again, you will see something that you don't expect to see. So you can see that it is not white. Okay. It is still black. Okay. You may not know why, okay, but I can tell you, okay, different guess. That's because say when you write programs, graphics programs, everything is buffered. Okay. So it won't send to the screen until you flush it. So you have to do this command, GL flush. We compile this, okay? Now you can see that it is white, right? So this is quite important, especially for beginners. So if you forget this, geo brush, you write a lot of things and change, you not see the effect because you forget this command.
So the buffer is only in memory, and the flush is what makes it go to the screen?
Yeah, to push it all the way to the output device. Yeah. And now let's here the display. Suppose now we can write something. You can define color. GL color with free F 0 0 0 0. This means to draw with black color. And now let's draw something real simple. GL begin. GL. Nice, we just draw some lines. GL. And now here we define the vertices. GL vertex 2i. Okay. Maybe we start from 50 from the point. 50. Okay. And another one, draw from this point to maybe 500 to 400. You can draw another point, draw another line. And this is from maybe endpoint slightly difference. So draw two lines. Again, let's compile this. Yes.
I thought all the vertexes had to be capitalized at the start.
Oh, yeah, you're right.
GL
Very
capital
good,
V
yeah.
vertex.
Very good. Thank you. Yes, very good. Okay, now, so let's compile it. Okay, compounds. Again, you may not see what you expect to see. So you don't see any line, right? Okay, that's what you expect to see. We don't see any line because we missed one step. Okay. We have to define the coordinate system, and we haven't. Okay. Now we know that here from here to here is 600 and 500, but we need to define something called world coordinate. We use this command. Okay, you always do it like this. So what we need to do is to use these few commands to define the coordinate system. Define a coordinate system. Okay. We use this command called GL matrix mode GL projection. And in OpenGL, everything is done using matrix. Okay. You start with the identity matrix, which is done by this command GL low identity. Okay. We'll discuss this in the future in detail. Okay. And then this defines the coordinate system. GL a group of 2D. Okay. From 0 to 600. Okay. And from 0 to 500. Okay. So we define the coordinate system. So the x-axis is from 0 to 600. Okay, and the y-axis is from 0 to 500. So after we have defined this, yes, we compile this. So again, you can see that we missed this command. What we need to do is to link to this library. LU. Okay, so it compiles. Sure. So now you can see the two lines. Okay. Okay. These two lines.
Professor,
Yes.
I just want to ask, is the command in terminal to build the program and compile it different?
You, well, so that means you want to put this into one command, right? But you can write a file to do it. Or another way to do it is to do a Makefile. Let me show you how to do this. Yeah, we can do a Makefile. Put all this together. Let me copy this. What we need to do is to create a Makefile. In the Makefile, we define macro pro, we got draw, okay, the program name, and we define the libraries to be what we just copy. So these are the libraries that we need. Okay. The libs. And we define the source. The source code here is very simple. The source is obviously as these are macros. Is this pro, which is draw actually, okay. Dot CPP, okay. And then the objects, OpenGL objects, okay, is the SLCS source, okay, with dot CPP replaced by .o, okay, and we get the object files.
Is that 0 or
O, good, so it should be an O. It should be an O. And then to get this, so this is our target. To get the pro, the ROG, the pro is our job. This depends on the objects. We need to use tab. Tab here, G plus minus O. Okay. We can use a shorthand writing. Okay. The $ add, that means this will be evaluated to the target. That's the pro, that's the job. And $, OBJS, we just link this together along with the libraries that we discussed. And to get the objects, we need to compile them like this. G++ minus C. $, is the primary part dot CPP. OBJ. Okay. The primary part of this OBJS. Okay. And .cpp compile the source code, basically. Let's do one more command, that's to do the clean. We need to remove all the object files. Okay, so we have this, after we have made this make file, so we can say make. Okay. So make. This is up to date because draw.o is there. We haven't modified the source code, so we can do a make clean. Okay. So you can see that we have removed draw.o. Now we can do the make. Okay. So the make will execute this command. This is the make file, right? Make execute this command first at g plus minus c. Okay. Draw.cpp, and then after that, execute this g plus minus o to produce object file. Okay, we have this draw.o. Okay, and then link with this libraries. That's what it does. So we get the same executable.
Oh,
Okay. And with this, it is more convenient. So let's add a few more to our program. Okay. So we can draw another line, maybe with different colors and different length. So here we define GL 9 report 1. And then here we define a big line. So we have say 4. And then we draw with a different color. It's just red. Okay. And one here. You copy this now. And this different endpoints. So we join with different width and different endpoints. Okay. So again, we need to remove the object files, make clean, and then make. For the system. System maybe doing something else, so it's sometimes try to slow. Okay. Compiles, okay, eventually spaces. So you can see that, right? This were the original 2 lines, black, right, and thin, line with 1, and this are red, okay, for these commands, and with line with 4, okay. So you have seen how to draw different lines now with different colors, okay. And next time I'll show you how to do more sophisticated things, okay, how to change color, how to use the mouse, etc.